a major sting operation. Crews in Washington state destroyed the first murder hornet nest of the season.
This isn't just a story about bugs. It's a detective story where the villain can fly 20 miles an hour and carries venom that melts flesh. The detectives were the Washington State Department of Agriculture, the scene of the crime, the misty forests of the border. They caught the bad guys in 2020. They wiped them out.
Dozens of the invasive insects trapped inside that long, clear tube. The nest of Asian giant hornets, an invasive species, was the first ever found in the United States.
But then, a year later, a single trap captured something that shouldn't have been there, a queen. The data didn't make sense. They realized the hunt wasn't over. It was actually just getting started. The day the bees died. In the misty, green lowlands of Whatcom County, Washington, right where the mountains touch the sea, something alien arrived. It was late 2019. The world was normal, traffic was moving, and farmers were tending their crops. But in the deep woods near the Canadian border, a low, heavy buzzing sound began to echo through the trees. This wasn't the sound of a normal bumblebee or a yellow jacket. It sounded like a miniature drone. A local resident spotted it first. A dead insect, massive and terrifying, skewered on a nail on their porch. They sent a picture to the authorities. When the photo landed on the desk of Sven Spischiger, an entomologist for the state, his blood probably ran cold. He knew exactly what he was looking at. It was Vespa mandarinia, the Asian giant hornet. The media quickly gave it a name that stuck, the murder hornet. And for once, the scary nickname wasn't just clickbait. This thing is a biological tank. It's 2 inches long, that's the size of a human thumb. It has a bright orange head, massive jaws that look like wire cutters, and a stinger that can puncture a beekeeper's protective suit. But here's the deal. The danger isn't just that they are big, it's what they do. These hornets are native to East Asia. Over there, the local bees have learned how to fight them. But here in America, our European honeybees are sitting ducks. They have absolutely no defense. When a murder hornet scout finds a honeybee hive, it marks it with a pheromone. It's basically painting a target on the hive for an airstrike. Then the slaughter phase begins. This is the part that keeps farmers awake at night. A squad of hornets, maybe 10 or 20 of them, descends on the bee colony. They don't sting the bees. That would take too long. Instead, they use those massive jaws to chop the heads off the bees. They are efficient killing machines. A single hornet can decapitate 40 bees in 1 minute. In less than 90 minutes, a small group of hornets can wipe out a colony of 30,000 bees. They leave a carpet of severed heads and bodies on the ground. Then they enter the hive, steal the bee larvae, and feed them to their own young. It's brutal. It's violent. And it was happening in Washington. The stakes were incredibly high. This wasn't just about saving a few bugs in the forest. Washington State is a massive agricultural hub. We're talking about raspberries, blueberries, cherries, and apples. These crops rely on pollination. If the murder hornet established a foothold, it could destroy the pollination industry. We are talking about hundreds of millions of dollars in damage. Panic started to ripple through the community. Beekeepers were terrified. If you're a beekeeper, your hives are your livelihood. Imagine watching your livestock get massacred in an hour by a predator you can't stop. By April 2020, the situation escalated. Live hornets were spotted buzzing around backyards in Birch Bay. The queens were waking up from hibernation. A queen hornet is huge, menacing, and looking for a place to build an empire. If those queens established nests, they would pump out hundreds of workers. Those workers would then create new queens next year. The math was terrifying. One nest this year could mean dozens of nests next year. The Washington State Department of Agriculture, WSDA, realized they had a very short window. They had to find the nests and destroy them before the breeding season in the fall. If they missed that window, the hornets would spread down the coast into Oregon and California. So the hunt began, but this wasn't like hunting for a lost cat. They were looking for a needle in a haystack, and the needle could fly 20 miles an hour and put you in the hospital. The state set up a hotline. They asked citizens to make traps using orange juice and rice wine. Thousands of plastic bottles were hung from trees across the county. Everyone was obsessed with catching one. But catching a worker was only step one. The real goal was to find the base of operations, the nest. And getting to the nest required technology, luck, and nerves of steel. They had to catch a live monster, glue a radio to it, and follow it home. The false scent of victory. So, how do you find a hidden fortress in a dense forest? You turn the enemy into a traitor. The plan sounded like something out of a spy movie. The scientists needed to catch a live hornet, keep it calm enough not to sting them, attach a tiny radio transmitter to its body, release it, and then run through the woods following the signal. It sounds simple on paper. In reality, it was a nightmare. First, the tech. The transmitters were incredibly small, but for an insect, they were like carrying a backpack. If the glue was too heavy, the hornet couldn't fly. If the glue didn't set fast enough, the hornet would chew the tag off. There was a lot of trial and error. They tried dental floss. They tried super glue. They had to chill the hornets in coolers to make them sleepy just to handle them. And remember, while they are doing this, they are handling a creature that carries a potent neurotoxin. A sting from a murder hornet isn't just painful, it can cause necrosis. That means the tissue around the sting dies and turns black. Multiple stings can shut down your kidneys. The team had to wear special suits. These weren't the thin white suits regular beekeepers wear. These were thick, padded foam suits that looked like bomb disposal gear. They were hot, heavy, and hard to move in. Summer 2020 passed with a lot of false starts. They would catch a hornet, tag it, and then the signal would vanish. The dense trees in Washington bounced radio signals around. It was frustrating. The clock was ticking. Every day meant the colony was getting stronger. The queens inside were getting ready to leave and start new colonies. Then, in October 2020, they got a break. A trap caught a few live workers. The team, led by Sven Spikiger, rushed to the scene. They managed to tag a hornet they called Agent 1. They released her. She flew up, circled, and headed into the woods. The team scrambled after her, holding antennas high, listening for the beep, beep, beep of the receiver. They tracked her to a private property in Blaine, Washington. The signal led them to a dead alder tree. They listened closely. Inside the tree, they could hear it, a furious, rhythmic scratching and buzzing. They had found it. The first murder hornet nest ever discovered in the United States. It was a massive adrenaline rush. But now came the dangerous part, extraction. They couldn't just burn the tree down, they needed to study the specimens. They needed to know if any queens had already escaped. They arrived before dawn on October 24th. It was freezing cold. They wrapped the tree in plastic wrap to prevent escapees. They drilled a hole into the trunk. Then they inserted a specialized vacuum hose. It was a literal vacuum cleaner but modified for combat. As soon as they turned it on, the hornets went crazy. They poured out of the nest to defend their queen, but they were sucked instantly into the containment chamber. The sound was intense, the hum of the vacuum mixed with the angry thudding of huge hornets hitting the plastic canister. After the vacuuming slowed down, they pumped carbon dioxide into the tree to knock out any stragglers. They sealed the tree and cut it down. When they opened the tree up later in the lab, the numbers were shocking. There were nearly 500 hornets in that one nest. But the scariest part, there were nearly 200 queens in various stages of development. Think about that math for a second. If they hadn't found that tree, 200 potential queens could have flown out. Even if only 10% survived the winter, that would be 20 new nests the following year, then 200, then 2,000. It would have been an explosion. The eradication was hailed as a massive success. It was all over the news. The murder hornets are defeated. The team felt a sense of relief. They had proven that the tracking method worked. They had stopped the slaughter phase before it could decimate the local farms. The winter of 2020 to 2021 was quiet. The snow fell, covering the woods. The traps were empty. The citizens stopped looking at every bug with suspicion. There was a feeling that maybe, just maybe, they had caught it early enough. Maybe it was a one-and-done situation. But here's the thing about invasive species. They are survivors. They don't give up just because you took out one base. Biology is a numbers game, and the numbers were about to turn against the humans. While the scientists were analyzing the data from the first nest, deep in the soil somewhere nearby, a queen was sleeping. She had escaped before the vacuum trucks arrived. She was curled up waiting for the warmth of spring. And she wasn't alone. As 2021 rolled around, the state prepared for a mop-up operation. They expected maybe a stray hornet or two. They didn't expect the war to restart with double the intensity. The hubris of the first victory was about to fade. The summer of 2021 was hot, and in the heat, the buzzing returned. This time, the reports were different. The hornets were being spotted in the same general area, but the patterns were weird. The tracking data was confusing. In August 2021, the team caught another live hornet. They did the drill: cool it down, glue the tag, release it. They followed the signal. It led them to another tree. Victory number 2. They did the vacuum procedure again. They high-fived. They thought, okay, that must be the straggler from last year. They destroyed the nest. They packed up their gear. They thought the season was over, but then a few weeks later, the traps pinged again. And this is where the stomach drop moment happened. They caught a hornet. They tagged it. They released it. Logic dictated it should fly back to the area of the nest they just destroyed. Maybe a confused worker looking for a home that was no longer there. But it didn't. The hornet flew in the complete opposite direction. The scientists looked at their GPS. They looked at the flight path. The realization hit them like a ton of bricks. That hornet wasn't lost. It was going home. And home wasn't the nest they just destroyed. It was heading toward a third nest that nobody knew existed. September's nasty surprise. The atmosphere in the command center changed instantly. The celebration vanished. Finding one nest was hard. Finding a second one was a grind. But realizing there was a third one? That was terrifying. It meant the infestation was worse than their models predicted. It meant that multiple queens had survived the winter of 2020. The timeline was tight. It was September. The new queens would emerge in October. They had weeks, maybe days, to find this new target. The team went back into the field. The brush in Whatcom County is unforgiving. It's full of Himalayan blackberry bushes, which are invasive themselves and covered in sharp thorns. You can't just walk through them, you have to hack your way through with machetes. Now imagine doing that in a suit that makes you overheat while trying to hear a tiny radio beep. The tracking of the third nest was frustrating. The signal would bounce off trees. The hornets would fly over ravines where the humans couldn't follow. The battery life on the radio tags was short. If the battery died before they found the tree, they had to start all over again. Catch a new hornet, tag it, release it. And catching them was getting harder. The hornets seemed more cautious. Finally, the signal led them to a new location. But this one was different. The first two nests were high up in alder trees. This signal seemed to be coming from the ground. This was a curveball. While Vespa mandarinia often nests in the ground in Asia and Washington, they had been tree dwellers. If they were moving underground, that changed the game. An underground nest is harder to spot. You can walk right over it without knowing until the ground explodes with angry hornets. It turned out the signal wasn't underground, but the nest was much lower than before. It was in a different type of tree, hidden deeper in the canopy. They found nest number 3. It was located just a few miles from the previous one. This proximity was alarming. It meant the area was a hot zone. The hornets were clustering. The extraction of nest number 3 was tense. When they opened up the tree, they found something that kept them up at night. This nest was healthy, it was robust, and it was churning out reproductives, the next generation of queens. If they had stopped after nest number 2, thinking the job was done, nest number 3 would have released hundreds of queens. The invasion would have been unstoppable. This moment was the turning point in the entire campaign. It proved that detection was the most important part of the puzzle. You can't kill what you can't find. It also highlighted the needle in a haystack problem. The area they were searching was small in the grand scheme of the United States, but huge when you were looking for a bug. The scientists realized they needed more than just radio tags. They needed to understand the mind of the hornet. They started analyzing the DNA of the hornets. This is where the science gets really cool. By looking at the genetics, they could tell if the hornets from nest 1, nest 2, and nest 3 were related. Were they sisters, cousins, or were they separate invasions? The DNA results showed they were all connected to the same introduction. This was good news. It meant they were fighting a single family tree, not multiple invasions from Asia. If they could prune this family tree down to 0, they could actually win. But the anxiety remained. Were there more? Was there a nest number 4? The team kept trapping through November. The rains came, the temperature dropped. The hornets died off naturally as winter set in. The queens that had already escaped, if any, dug into the soil to sleep. The year 2021 ended with a mixed feeling. They had destroyed 3 nests in total since the start. That was a victory. But the fact that there were 3 nests meant the first year's containment hadn't been perfect. The media interest started to fade. People moved on to other news. But for the WSDA, the war was entering a cold phase. They had to prepare for 2022. They had to upgrade their arsenal. They brought in experimental traps. They worked with the USDA to get better radio tags. They even discussed using radar, and get this, they even looked into using sniffer dogs. Yes, dogs trained to smell the specific pheromone of the murder hornet. The challenge with dogs, though, is that you don't want your dog to get stung. So finding a way to protect the dogs became a project in itself. The fear was that the hornets would adapt. Invasive species often change their behavior in a new environment. If they started nesting exclusively underground or deep in the blackberry brambles where humans couldn't reach, the vacuum method wouldn't work. The second nest incident of 2021 served as a wake-up call. It showed that one success isn't enough. You have to be paranoid. You have to assume the worst. As the spring of 2022 approached, the team held their breath. They had thousands of traps ready. They had the suits cleaned and prepped. They were ready for another season of war. But nature is unpredictable. Sometimes the silence is the scariest part, because in 2022, the signals stopped coming. Ghost hunting in the woods. 2022 was supposed to be the year of the big battle. The models predicted that despite the eradication of the 3 nests, some queens must have slipped through the net. The state deployed over 1,000 traps. They enlisted citizen scientists, regular people who volunteered to monitor traps in their backyards. There was an app where people could upload photos of suspicious bugs. Every orange wasp, every large beetle, every cicada killer was reported. The team sifted through thousands of reports. They waited for the slaughter phase. They waited for the decapitated bees. But nothing. Spring passed, summer passed. The blackberries ripened and rotted. Not a single confirmed sighting of a northern giant hornet, the new official name, by the way, since murder hornet was a bit too dramatic for the scientists. This silence was confusing. Was it a trap? Were they hiding better? Or had the team actually done the impossible? Eradicating an invasive species once it has established a foothold is almost unheard of. Look at the fire ant. Look at the kudzu vine. Look at the Burmese python in Florida. Once they are in forever. You can manage them, but you can't delete them. But the murder hornet might be the exception. Why? Because of the bottleneck. Since all the hornets came from a very small starting population, maybe just 1 or 2 queens arriving on a cargo ship from Asia, they were vulnerable. They didn't have genetic diversity. And because the WSDA hit them so hard and so fast in 2020 and 2021, they might have pushed the population below the survival threshold. It's like trying to start a fire in the rain. If you stomp out the first few sparks, the fire never catches. If you wait until the whole forest is burning, it's too late. Washington stomped on the sparks. 2023 came, still nothing. The tension started to turn into cautious optimism. The scientists didn't want to jinx it. There is a rule in pest control. You can't declare victory until 3 full years have passed without a detection. So they kept trapping. They kept the hotline open. During this quiet time, the scientists learned a lot about what could have happened. They ran simulations. They realized that the lush forests of Washington were actually a perfect barrier in some ways. The hornets like specific temperatures. They don't like it too hot and they don't like it too dry. This limited where they could spread. Also, the local animals might have helped. Bears, raccoons, and skunks love to eat hornet larvae. In Japan, these predators act as a natural control. In the US, maybe the local bears found the ground nests and ate them before the scientists even found them. We will never know for sure. But let's talk about the what if. What if they hadn't found that second nest in 2021? Models suggest that by 2025, the hornets would have reached the southern border of Washington. By 2030, they would be in Oregon. The Willamette Valley in Oregon is one of the world's best places for growing berries. The economic devastation would have been in the billions. And it's not just about money, it's about the ecosystem. If the honeybees die, the wildflowers don't get pollinated. The food chain collapses. Birds that eat the berries starve. It's a domino effect. The fact that they found that second and third nest just in time is a miracle of modern science and hard work. It was a combination of low-tech plastic bottles filled with orange juice and high-tech radio telemetry. But here's the catch. We can never be 100% sure there are millions of acres of uninhabited forest in the Pacific Northwest. A colony could be thriving deep in a ravine where no human has walked in 10 years, and there is always the risk of reintroduction. Global trade hasn't stopped. Ships from Asia arrive in Seattle and Vancouver every single day, containers full of car parts, electronics, and timber. Any one of those containers could hold a sleeping queen. The systems they built, the traps, the reporting apps, the trained response teams, are not just for the hornets that were here, they are for the hornets that might come next. It's a permanent shield. In late 2023, the data was reviewed, still 0 detections. The clock of eradication was ticking closer to the finish line. The scientists who had spent sleepless nights tracking these monsters were finally starting to breathe easier. Sven Spichiger and his team had done what everyone said was impossible. They beat the invasion. But nature always has one last card to play. Just because you don't see them doesn't mean they are gone. And a recent study suggests that the danger might be sleeping longer than we thought. 3 years of silence. December 2024. The magical 3-year mark. According to international standards, if you go 3 full years without finding a single specimen of an invasive species, you can declare it eradicated. The Washington State Department of Agriculture prepared the paperwork. It was a historic moment. They had beaten the odds. They had saved the bees. But let's not pop the champagne just yet. A study from Georgia Tech threw a bit of a wet blanket on the party. They analyzed the climate data and the biology of the hornet. They found that in some conditions, queen hornets can stay dormant for longer periods or maintain extremely low-level populations that are invisible to traps for years before exploding again. It's called a cryptic population. Essentially, the hornets could be playing the long game. They could be surviving in such small numbers that they don't trigger the traps, slowly building up their genetic diversity until they are ready to launch a new slaughter phase. And then there is the British Columbia factor. The hornets didn't respect borders. They were also found in Canada, just across the line. While Canada also fought hard to eradicate them, the wilderness up there is even more vast and inaccessible. If a nest survived in the Canadian Rockies, it's only a matter of time before they drift south again. So what is the legacy of the murder hornet hunt? It changed how we look at invasive species. It proved that citizen science works. The government couldn't have done this alone. They needed the thousands of eyes of regular people. It was the community that saved the bees. It also showed us how fragile our food system is. We rely so heavily on the European honeybee. It is a single species that supports 1/3 of our diet. When a predator appears that can wipe them out, it reveals a weakness in our armor. The hunt gave us new technology. The radio tagging methods refined in Washington are now being used to track other pests. The public awareness campaigns became a blueprint for how to handle future invasions. But the most important lesson is about hubris. Remember back in 2020 when they found the first nest? They thought they won. They celebrated and they almost missed the second and third nests that would have doomed us. We are at that point again. We think we won. The data says we won, but the woods are deep. The mist in Whatcom County hides a lot of secrets. For now, the bees are buzzing safely. The almond trees and the blueberry bushes are blooming. The nightmare seems to be over, but every time a farmer in Washington hears a low, heavy buzz in the distance, they pause. They look up and they wonder, is it gone? Or is it just waiting? The murder hornet hunt was a success. A magnificent, improbable success. Until the next container ship docks, until the next queen wakes up. The price of safety is eternal vigilance. And in the world of invasive species, the war never truly ends. It just goes quiet. So the next time you see a bee landing on a flower, take a second to appreciate it. And appreciate the people who walked through thorns, climbed trees, and vacuumed monsters to make sure that bee could survive because we won this round. But nature always demands a rematch. So do you think they are really gone, or are they just hiding deep in the Canadian wilderness, waiting for a comeback? It's scary to think how close we came to losing our entire bee population. If you enjoyed this deep dive into the war on nature, smash that like button and subscribe for more stories about the things that go bump in the night.